Hi guys! In this video, we are going to learn how to solve equations with two variables. This is a required skill in the SAT math test. Watch this video and you'll master it and even start enjoying it. The essential idea to solving equations with two variables is to turn them into equations with one variable, which we already know how to solve. It means we need to find a way to eliminate one variable, but how? Before we start, please subscribe to our channel and don't forget to click the bell button to turn on notifications. Let's get started. We have two methods to do that. One is the elimination method and the other is the substitution method. In this video, we're going to talk about the first one. The second one will be explained in the next video and I will post a link of it in the video description. Let's look at a real-world problem. The International Academy, IA, is a high school in Michigan. They have a field trip to Mackinac Island. 40 students can rent bicycles to ride around the island. There are two types of bicycles, 2-seat bicycles and 3-seat bicycles. They rent 16 bicycles, all seats are taken, and everybody has a seat. So how many 2-seat bicycles and 3-seat bicycles do they rent? As we've learned, unknown variables should be represented by letters. You can use any letters you like, but typically we use X to represent the first variable and Y to represent the second variable. What if there is a third variable? Right, we use Z. In this example, we assume X represents the number of 2-seat bicycles and Y represents the number of 3-seat bicycles. Okay, then we create the equations. One important rule to pay attention to is that the number of equations must be equal to the number of unknown variables. That means if we have one unknown variable, it requires one equation. If we have two unknown variables, it requires two equations. What if we have three unknown variables? Yes, we need three equations. In this case, we have two unknowns, so we need two equations to get solutions. 40 students rent bicycles and all seats are taken. That means the number of seats equals 40. 2x plus 3y equals 40. This is the first equation. We know that the total number of bicycles is 16. We get x plus y equals 16. That would be our second equation. That's it. We have two equations, and it's not difficult at all, is it? We call the first equation 1 and the second equation 2. The next step is to solve the equations. Let's take a closer look at these two equations. In equation 1, the coefficient of x is 2, and in equation 2, the coefficient of x is 1. If we make the two coefficients the same, can we eliminate x by subtracting the two equations? Great idea, let's try it. For equation 2, we multiply both sides by 2. We get 2x plus 2y equals 16 times 2, which is 32. It's a new equation, we call it equation 3. Now equation 1 and equation 3 have the same terms, 2x. We subtract equation 3 from equation 1. For the left side, 2x minus 2x equals 0. X is eliminated. 3y minus 2y equals y. For the right side, 40 minus 32 equals 8. We got the solution, y equals 8. The next step is to solve x. We can plug y equals 8 to any of the three equations we have. For example, we plug y equals 8 into equation 2 because it looks the simplest. X plus y equals 16, x plus 8 equals 16. We move plus 8 to the right and change its sign and we get x equals 16 minus 8. If you're not familiar with this transposition trick, check the link in the top right of the video. Okay, we get x equals 8. That is, they rent 8 2-seat bicycles and 8 3-seat bicycles. Okay, let me ask you a question. If in equation 2, the coefficient of x is not 1 but -1, how can we eliminate x? We can still multiply both sides by 2 and get equation 3. And then we eliminate x by adding two equations. After understanding this method, no matter what the coefficient is, it won't be a problem for us. The main idea of the substitution method is that we solve one of the equations for one of the unknowns, and then substitute the result into the other equation. This way, we turn the equations with two variables into equations with one variable. Let's look at the same equations as the previous video and try to solve it by substitution. Equation 1, 2x plus 3y equals 40. Equation 2, x plus y equals 16. It doesn't matter which equation we choose first, just choose the most convenient one. In equation 2, the coefficients of x and y are 1, so we choose equation 2. We solve it for one of the variables, for example, solve for y. That means we move all items except for y to the right side. There are two ways of transposition. The first way is to subtract x on both sides. The left side, x minus x equals 0. The right is 16 minus x. We get y equals 16 minus x. The other way of transposition is to move the item directly to the other side and change its sign to the opposite one. In this case, we move x to the right side and turn positive x to negative x. If you're not familiar with this transposition trick, check the link on the top right of the video. This trick can save you lots of time by solving complicated equations. As you know, time is very tight in the SAT math test. You must do it fast to finish all questions in time. That's why I highly recommend you to master this trick. Okay, now we have successfully used x to represent y. The next step is to plug the result into the other equation, which is equation 1. Let's do it. We get 2x plus 3 times, in parentheses, 16 minus x equals 40. 2x plus 3 times 16 minus 3x equals 40. 2x minus 3x equals negative x. 3 times 16 equals 48. We get negative x plus 48 equals 40. Then keep the items with x on one side and other items on the other side. Usually we keep the items with x on the left, but in this way we will get a negative number temporarily. I don't like negative numbers because I'm lazy, so let's move negative x to the right side and change its sign to have positive x, and move 40 to the left side and get minus 40. 48 minus 40 equals 8. We get the solution, x equals 8. Okay, now we get the value of x, and then we can plug it into either equation. Equation 2 is simpler, so let's plug x into equation 2. That is 8 plus y equals 16. Move 8 to the right side, and it becomes negative 8. 16 minus 8 equals 8, y equals 8. And that's it. Substitution is not that difficult, right? Okay, now we've learned the elimination method and the substitution method. When solving equations with elimination, we make the coefficients of one of the variables in two equations the same or opposite, and then eliminate it by adding or subtracting two equations. When solving equations by substitution, we solve one of the equations for one of the variables, and then substitute the result into the other equation. In practice, you can choose the one that you feel more comfortable with. we learned how to solve equations with two variables by elimination and substitution. We will compare these two methods through two examples. In this system of equations, equation 1 is 3x plus 4y equals 18. Equation 2 is 6x plus 5y equals 27. First, we solve them by the elimination method. The main idea of the elimination method is to make the coefficients of one of the variables the same or opposite in two equations, and then eliminate it by adding or subtracting two equations. In the two equations, the coefficients of x are 3 and 6. The coefficients of y are 4 and 5. So what should we do? In this case, we are looking for the least common multiple of the coefficients. The least common multiple of 3 and 6 is 6, and the least common multiple of 4 and 5 is 20. Of course, we choose the pair of 3 and 6, which is relatively simple. That means we're going to eliminate x. For equation 1, we multiply 2 on both sides and change the coefficient of x to 6. 2 times 3x is 6x. 2 times 4y is 8y. 18 times 2 is 36. This is equation 3. Then we subtract equation 2 from equation 3. 6x minus 6x equals 0. 8y minus 5y equals 3y. 36 minus 27 equals 9. We get 3y equals 9. So y equals 3. Then plug y into any of the equations. For example, equation 1. 3x plus 4 times 3 equals 18. 4 times 3 is equal to 12. Move 12 to the other side and get minus 12. If you're not familiar with this transposition trick, check the link in the video description. Okay, 18 minus 12 equals 6. 3x equals 6, so x equals 2. The solutions are x equals 2 and y equals 3, and that's it. Now let's try to solve this example by the substitution method. The main idea is to solve one of the equations for one of the variables and then substitute the result into the other equation. Take a look at these equations. We find that equation 1 with the small coefficients looks simpler, so we choose to solve equation 1 for either of the two variables. Let's solve for x. Move all items without x to the right side, move 4y to the right side and change it to minus 4y, and then divide both sides by 3. We get x equals 18 minus 4y divided by 3. Okay, let's plug this result into the other equation, which is equation 2. It becomes 6 times 18 minus 4y over 3 plus 5y equals 27. 6 divided by 3 equals 2. 2 times 18 equals 36. 2 times 4y equals 8y. And then negative 8y plus 5y equals negative 3y. Move negative 3y to the right side and get positive 3y because I hate negative numbers. And move 27 to the other side and get minus 27. 36 minus 27 equals 9. Divide both sides by 3 and get 3 equals y. That is, y equals 3. The following steps are the same as the elimination method. Plug y into any equation and get x equals 2. Okay, we solved this example by elimination and substitution. Which method do you think is simpler? Elimination is simpler, isn't it? In this example, the coefficients of x are 3 and 6. 6 is twice the value of 3. By multiplying both sides of equation 1 by 2, we can eliminate x very easily. But when we solve it by substitution, it's a little more complicated. Because all coefficients of x and y are not 1, if we use terms with one variable to represent the other variable, we get a fractional item. Therefore, for this example, elimination is simpler. What if the coefficient of x in equation 2 is 4 and not 6? How do you solve it by elimination? We just learned that the idea is to find the least common multiple. The least common multiple of 3 and 4 is 12, so we just multiply both sides of equation 1 by 4 and multiply both sides of equation 2 by 3. Then we have 12x in both new equations, so x can be eliminated by subtraction. Let's look at another example. X plus 4 divided by y equals 9. 1/5 x plus y equals 17. What is the value of x minus y? By solving equations, we get the value of x and y, and then calculate x minus y. Let's do it. First, we convert the fractions to integers. That will make it simpler. Consider what to do next. For equation 1, the denominator is 4, so multiply both sides by 4. 4 times x is 4x. Y divided by 4 times 4 is y. 9 times 4 is 36. We call this new one equation 3. For equation 2, the denominator is 5. Multiply both sides by 5. 1/5 x times 5 is x. Y times 5 is 5y. 17 times 5 is 85. This is equation 4. Take a look at the new equations. In equation 3, the coefficient of y is 1. That means we can solve for y easily. In equation 4, the coefficient of x is 1. That means we can solve for x easily. In this example, we choose equation 3 to solve for y, and get y equals 36 minus 4x. Then plug it into equation 4. X plus 5 times in parentheses 36 minus 4x equals 85. 5 times 36 equals 180, and 5 times 4x equals 20x. And then x minus 20x equals negative 19x. We get negative 19x plus 180 equals 85. Move negative 19x to the right side and get positive 19x. Move 85 to the left side and get minus 85. 180 minus 85 equals 19x. 180 minus 85 is 95, so we get 95 equals 19x. Divide both sides by 19, we get x equals 5. Plug x into any equation. We'll choose equation 3. 4 times 5 plus y equals 36. 4 times 5 equals 20. Move 20 to the right and get negative 20. Y equals 36 minus 20. Y equals 16. Okay, now you know x equals 5 and y equals 16. So x minus y equals 5 minus 16, which equals negative 11. And it's done. In this case, substitution is not difficult. Some students may ask, can you solve it by elimination? Of course. Let's try it now. We need the same or opposite coefficients of x or y in two equations. We choose x for example. For equation 2, multiply both sides by 5. We get 5 times 1/5 x plus 5y equals 17 times 5. X plus 5y equals 85. That is equation 3. Then subtract equation 1 from equation 3. X minus x equals 0. The left side is 5y minus y over 4. The right side is 85 minus 9 equals 76. Multiply both sides by 4. 5y times 4 equals 20y. Y times y over 4 equals y. 20y minus y equals 19y. Divide both sides by 19. We get 76 times 4 over 19. 19 is a factor of 76. 76 divided by 19 equals 4. 4 times 4 equals 16, and y equals 16. Plug y into any equation, for example, equation 1. X plus 16 divided by 4 equals 9. 16 divided by 4 equals 4. X plus 4 equals 9. X equals 9 minus 4, which equals 5. X minus y is 5 minus 16, which is negative 11. Now, we have the final result by substitution and elimination. Okay, let's get started with this example. Equation 1 is y equals negative x squared plus 5x minus 5. Equation 2 is y minus x plus 1 equals 0. How many solutions are there to the system of equation? We already learned that there's one solution in linear equations with two variables, but we have no idea how many solutions there are to quadratic equations with two variables. Don't panic, just solve it and we will see. But how to solve it? Well, the main idea is exactly the same as solving linear equations, by elimination and substitution. We'll try substitution first. That is, solve one of the equations for one of the variables and then substitute the result into the other equation. Of course, we choose equation 2 because it's simpler. If we solve for x, we get x equals y plus 1. Then plug x equals y plus 1 into equation 1. We will get in parentheses y plus 1 squared. That's kind of time-consuming to calculate it. If we solve for y and get y equals x minus 1, then plug it into equation 1, we get x minus 1 equals negative x squared plus 5x minus 5. Let's simplify it. Move everything on the right side to the left and change their signs. The negative x squared becomes positive x squared. Plus 5x becomes minus 5x. Minus 5 becomes plus 5. If you're not familiar with this transposition trick, check the links in the video description. X minus 5x equals negative 4x. 5 minus 1 equals 4. We get x squared minus 4x plus 4 equals 0. Does it look familiar? Yes, it's the perfect square formula. I also put a link in the video description for you to review the formula. Apply the formula and we get in parentheses x minus 2 squared equals 0. So x minus 2 equals 0 and x equals 2. Plug x into any equation, for example, equation 3. Y equals x minus 1. Y equals 2 minus 1, which equals 1. Now we know that there's only one solution to this system, that is x equals 2 and y equals 1. Okay, can you solve it by elimination? It's pretty simple, so I'll let you solve it by yourself. Now let me ask you a question. For a system of equations consisting of a quadratic equation and a linear equation with two variables, what is the possible number of solutions? How can we know that without seeing the equations we deal with? I'll leave this question to the next video. Stay tuned! Okay, let's get started. Do you remember the graph of linear equations? The linear equation is a straight line on a coordinate plane. Equation 2, y equals mx plus n, is a linear equation. When this linear equation is written as y equals mx plus n, the coefficient of x, which is m, represents the slope of the line. N is the intercept of the line. As we know, every solution to the equation is a pair that consists of an x and a y. And it's also a point with an x coordinate value and a y coordinate value. Given a point x, y, if the point is on this straight line, the values of x and y make the linear equation true, and vice versa. If the values of x and y make the linear equation true, the point x, y is on the line. Okay, let's look at the equation 1, which is a quadratic equation. What does its graph look like? We've learned it before. Now we walk through key points together. The graph of a quadratic equation is a U-shaped curve called a parabola. A is the coefficient of x squared. The sign on the coefficient a affects whether the graph opens up or down. If a is more than 0, the graph makes a smile, which means it opens up. And if a is less than 0, then the graph makes a frown, which means that it opens down. As we just mentioned, every solution is a pair that consists of a x and a y. It's also a point with a x coordinate value and a y coordinate value. Given a point x, y, if the point is on this curve, the values of x and y make the quadratic equation true. Vice versa, if the values of x and y make the quadratic equation true, the point x, y is on the curve. In other words, the solutions to the system of equations are the points on both the line and the curve. That means that those points are the intersections of the graphs. Therefore, the number of solutions is the number of intersections. If the curve looks like this, we move the line to a different location and see what happens. When the line is at position 1, there are two intersections. When the line is at position 2, it just touches the curve at one point and we call it the tangent line. There is one intersection point. When the line is at position 3, there is no intersection. The same thing happens when the curve opens up. So we get the answer to the question. There are three possibilities of the number of solutions: 2 solutions, 1 solution, or no solutions. It's not that difficult, is it? In the last video, we solved this system of equations and know it has only one solution: x equals 2 and y equals 1. If you forgot how to solve it, please check out the links in the video description. If the system of equations has only one solution, that means the line is the tangent line of the curve. If we draw their graphs, they look like this. When doing the multiple choice questions, we can draw a sketch and eliminate the wrong choices very fast. and it can save you a lot of time. Okay, that's all for today. If you have any questions, please leave your comments below or email us at question@beat-math.com. We will try to answer your question in the next video. See you next time!